Hello, my name is Andreas Rafalski. I am one of the staff sonographers here at Kidneys No Kidding, Inc. Here at Kidneys No Kidding, Inc., our core value is your kidneys are vital organs in your body to help maintain your proper health. A number of things can go wrong with your kidneys, many of which are either easily preventable or can be treated if addressed early enough. If you have a history of problems with your kidneys, if you're currently experiencing problems with your kidneys, or if you have concerns, please watch this video and contact us if we can be of further assistance to you. Kidneys are susceptible to damage and failure under certain life conditions, which requires medical attention for things like dialysis or kidney transplants. This can become a major life disruption. Therefore, it is important to understand the function of the kidneys and understand how to keep them running properly to keep you healthy. Under normal conditions, people usually have two kidneys, one on the right and left as depicted below. How exactly do the kidneys and their primary functional unit, the nephron, operate? I will be showing you through the parts of the kidney and nephron loop to help illustrate their functions. On the left here, we have, in our model, we have our kidney. Particularly what we're interested in is on the outer edge we have the cortex, and then on the inside we have what's called the medulla. Along the edge here, inside the medulla, are several pyramids that line out the whole interior of the cortex line inside here. So now one of these pyramids between medulla and cortex is highlighted here in a blown out view. So basically this represents what's called the nephron. The nephron basically consists of various blood vessels that are coming between the medulla and the cortex, and there's various different parts within the nephron which I'm going to illustrate in a little while. First off, one of the chief functions of the kidney is to process blood entering the kidney and extract waste products and turn them into urine. Interesting fact, on average approximately 5 liters of blood circulates through the human body every minute. That is pretty fast. Of those 5 liters of blood in circulation every minute, a little more than 1 liter of blood, that's approximately 20 to 25%, arrives at both kidneys every minute. So as with other organs, blood flow to the kidneys in part is to supply nutrients to the kidney. But the major distinction between the kidneys and other organs is that blood flow to the kidney is for the primary purpose of eliminating metabolic waste. Again, back to the kidney. So we have all the different vessels that are coming into the kidney, including the renal artery, the renal vein, and the ureter, which will pass urine out of the kidney and out of the body. The renal artery is being supplied directly from the aorta, so blood flows into the renal artery and is followed through by a network of arteries and arterioles that are basically supplying blood throughout the kidney. Now as the blood vessels are coursing up, they're going to come alongside the pyramid and then make basically a 90-degree turn. Now this here is called the arcuate artery. So this is also illustrated in our large scale view of the nephron. Basically we have this vessel here called the arcuate artery that travels along the edge of the pyramid, and then from here additional arterioles arise up from the arcuate artery, and then eventually they end up at an artery called the afferent artery, beginning with letter A, and it's one of 2 vessels that are entering into the first part of the nephron called the renal corpuscle. Notice that the afferent artery is wider or thicker or bigger than the what's called the afferent artery, which basically is taking the blood out of the renal corpuscle. As the blood is entering into the afferent artery, it enters into the renal corpuscle, which houses what's called the glomerulus, which is basically a network of capillaries that are winding their way through the renal corpuscle, and then basically on the opposite end, the blood flow is out the efferent artery. Basically, there's now the blood is being filtered through that glomerulus with a water waste mixture, which basically exits the corpuscle, the renal corpuscle here, and then enters into what's called the proximal collecting tubule, or also known as the PCT. The fluid passes through the PCT. It's very tortuous and winding in the very first section, and basically what it does is it comes up through here and it enters into what's called the descending tube. Basically, it's going to travel down this tube into a thinner section of the descending tube, and then it basically makes this 180-degree turn or bend and comes into what's called the ascending tubule, which is a little bit thicker again, and then basically it continues up through what's called the distal convoluted tubule. So proximal being closer to the glomerulus, distal being further away from the glomerulus. So the distal convoluted tubule, also known as the DCT, and basically this now transports the fluid into what's called the collecting duct. And if you notice, there's other tubes that are connected here that are located as well, which basically are representing other nephrons, just like this one, that are connecting to the same collecting duct and taking basically the fluid that it has, and it's basically at this point it's already converted into urine, and it passes down through the medullary area and then eventually out through the kidney. The four major nephron functions include glomerular filtration, tubular reabsorption, tubular secretion, and water conservation, which we will discuss next. Blood enters the renal corpuscle via the afferent arteriole and flows through the glomerulus within the renal corpuscle. There's a filtration membrane between the glomerulus and outer capsular space. Any substances in the glomerulus that are smaller than 3 nanometers can enter the capsular space, including water, electrolytes, amino acids, among others. Anything larger than 3 nanometers remains in the glomerulus and exits the renal corpuscle via the efferent arteriole. Here's another view of the nephron showing the ability of absorption or elimination of substances as fluid travels through the nephron, making adjustments in what is eliminated or absorbed depending on given conditions. Note too how the tissue surrounding the nephron is like a bath of water and various solutes, either awaiting to be eliminated or retained depending on the needs of the kidney. The remarkable feature of the nephron is that it can regulate itself and help regulate its environment depending on existing conditions. For example, the collecting duct can adjust water reabsorption to produce urine as either hypotonic or hypertonic, depending on the body's need for water conservation or removal. When a person is well hydrated, the hormone ADH drops its secretion activity. This makes the collecting duct less permeable to water. More water remains in the duct and you produce abundant dilute urine. In extreme cases, the blood pressure of a dehydrated person is low enough to significantly reduce the glomerular filtration rate. When the GFR is low, fluid flows more slowly through the renal tubule, and there is more time for fluid or tubular reabsorption to occur. Less salt remains in the urine as it enters the collecting duct, hence there is less opposition to the osmosis of water out of the duct and into the surrounding tissue. More water is reabsorbed and less urine is produced. One complication arising from the various compounds traveling through the kidneys is the condition known as nephrolithiasis. Urine naturally contains substances that promote the development of crystals, which are composed of calcium, oxalate, sodium, phosphorus, and uric acid. These compounds promote the conditions for nephrolithiasis, which is also known as kidney stones, which can occur in the kidneys. However, stones may also appear in other organs as well. In addition to conditions for promoting crystal formation, urine also contains proteins and other compounds that inhibit crystal formation. These inhibitors aid the elimination of crystals before they attach to the kidney and grow into larger stones. If the crystals remain small enough, and if the urine is diluted enough to avoid supersaturation, crystals will flow with urine through the ureters and bladder without being noticed or causing problems. Due to genetic, lifestyle, or other factors, often the conditions for nephrolithiasis outweighs the conditions for inhibiting stone growth and requires additional medical attention to help ensure proper health.